Welcome to this tutorial on basic operations with Numpy arrays. In this video, we will explore some fundamental operations you can perform with Numpy arrays, including element-wise operations, broadcasting, mathematical functions, and deep copies. Numpy allows us to perform element-wise operations on arrays, making it easy to work with data at the individual element level. Element-wise operations are applied to each element of the array individually. Let's see some examples. So at first we have to create some example data. So here we have this 2x2 matrix and another 2x2 matrix. And now we can apply this element-wise operations like addition. And if we want to add these two matrices together, we can simply use the plus operator, or we can use np.add and use both function as an argument, and then we get both matrices added together. And you can see both function calls result in the same result. And yeah, we can do the same for subtraction, multiplication, division, and we can also use np.square root to apply the square root on each element in the matrix. Okay, now we get on to the next topic, the so-called broadcasting. Broadcasting is a powerful feature of Numpy that simplifies operations between arrays of different shapes and dimensions. Numpy automatically broadcasts small arrays to match the shape of the larger array. This enables element-wise operations even when the array shapes doesn't match. Here we can see a small example. So again, we have a 2x2 matrix, and now we want to multiply it by 2. So we have the scalar, and we can simply multiply the array with the scalar. And if we take a look at the result, we can see each element in the array, in the matrix got multiplied by 2. Now we're gonna move on to mathematical functions in Numpy. Numpy provides a wide range of mathematical functions for working with arrays. You can perform operations like dot product, matrix multiplication, and more using Numpy's functions. Here are some examples. At first we have to create some example data like always, and here we have two matrices, x and y, and two vectors, v and w. And now we want to calculate the dot product of these vectors, and we can either do this by calling the dot function on one of the vectors and using the other as an argument, or using the np.dot function and pass both the vectors as an argument, and we can see both produce the same output. There exists also the matmul, so matrix multiplication operator, and the output appears to be the same as for the dot product, but there we have to be a little bit careful when working with arrays of higher dimensionality, so larger than 2. And here's an example. So we create two random 3-dimensional arrays, and we can here see the shape. We also passed in here. And then if we use the dot product and matrix multiplication, we can see these produce different output shapes. For matrix multiplication, we can not only use this np.matmul, but we can also use the add operator. And here you can see it produces the same output. Here we have an example where we calculate matrix with vector products, and we can see they always produce a rank 1 arrays. And if we have matrix products, we can see they produce rank 2 arrays or 2-dimensional arrays, and rank 1 arrays are 1-dimensional arrays. Okay, now we get to a last example for mathematical functions. So if you are working with Numpy, you will frequently have to transpose your data, and you can simply do this by calling dot large T on your matrix or vector, and you will get the transposed matrix. And you can see this here, we have this matrix, and if we print dot T, we get a transposed matrix, and here if we have a row vector, we can transpose it to a column vector. The last topic of this tutorial are deep copies. When working with Numpy arrays, it's essential to understand how copies are created. Modifying an array might influence other variables if they reference the same object. We can create independent copies known as deep copies to avoid this. Here's an example. At first we're gonna have to create a new array that we want to copy. Here this is our x. Then we want to copy it to a new variable called y, and we do this simply by calling y equals x. And then if we take a look at if y is x, it prints true. But now we can see one problem. So we're going to take a look at the position 0, 0 in the y matrix. And this is 1. We can also see this here. And then if we assign 42 to the first element in the matrix, we can see that if we print y, it worked, we have 42. But now if we also print x, it also prints 42. This is because we didn't create a real copy, but we only referenced the same x object with this y equals x. So everything you do to the one object also happens to the other object, and in fact they are the same object, so they only take up the space of this one array. But there's an easy fix for this. So if we call x.copy and set y equal to x.copy, we can test the same thing. And here again we print the first element, which is now 42, and then we set it to 7. And if we print it, we can see it's 7, but the element in x is still 42. So this created a new object, and you can modify each object without modifying the other object. But now they take up double the storage because you have two real objects.